So, 13, right? You do all the groups are all 13. I mean, notice, see how this from group A to group B, this went down by 3, but then this went up by 3. This went down by 2, this went up by 2. Of course, the average is going to be the same. And the middle is the same in all of them. So the median is going to be the same, right? So, I mean, you quickly see that they're all going to come out with the same measure of center. But they are not the same sets of data. So what I'm trying to get at is there are two numbers that we can calculate that summarizes a set of data really well. One of them is the center. And the center that's going to win, the most useful center in most situations, is the mean. So that's the one we're going to use the most, is the mean. So when you get down here to your no. So when you get down here, you get the 10801, right? And then, what was it? Was it? And then you get 22222, right? And 3, 1, 2, 1, 3. Okay. So using this center, how far away does the data get from the center? That's the measurement that we haven't figured out how to take yet. We could tell which one of these would have the biggest. So if we came up with a formula that measured the spread, which one of these should have the biggest number spread? D. This one. This gets more away from its center than any of the other ones do. This should have a very small spread, because most of its data is the freaking center, and then it has a couple that kind of got away. Right? This one, most of it is on the extremes, and there's a couple in the middle there. So that's going to have the biggest. So whatever this number is that we create, it's going to be larger for this one, smaller, smallest for this one. So the two together. So let me ask you this. All right. This is funny because I know you all know about this. There's a website called Rate My Professors.
Amazing.
I know, right? And I always tell my students, if I don't get a few bad reviews, I am not doing a good job. I don't know if you guys understand that. I actually don't give a shit if you understand. I need bad reviews because I have bad students, and if they don't think poorly of me, I'm not a good teacher. And if you think about it, that'll make sense. So I want some bad reviews. Not all. I want some nice reviews too, but I need bad reviews because they suck. But there's another website that not as many people know about, that thankfully you have to pay a little bit to get into now, and it tells you grade distributions for teachers. So I'm not going to tell you what it is now, but it's public domain knowledge. You can actually call the school and they have to tell you grade distributions teachers have given over the years in certain courses. So if let's say there's 2 teachers you're considering taking. Stay with me now. Everything, their Rate My Professors is like exactly the same. They're exactly the same kind of person, like clones. So everything's the same, right? And they both give an average of a C to their students. But one, and let's say you're at university, where a D is passing, okay? Because here, a D, you don't transfer. Too bad. So one gives between a B and a D. That's the spread. And the other one gives between an A and an F. That's their spread. Which one do you take? I love you guys. Those are 2 things I didn't say. You're like, screw your 2 guys. I found somebody else on my imaginary list. No, one gives from a B to a D, and the other one gives an A to an F. They both give an average of C. So the right answer is, I don't know yet. If I know I'm going to kick ass in that class, I'm not going to take the guy that never gives a frickin' A. I want the guy that actually gives A's. I had a class, I got the highest grade. I'm still bitter about this. And I got a B+. And I got the highest grade. Sorry, I'm still bitter. But if I know I'm going to suck, I'm going to take the one that never fails anybody. Right? Unfortunately, that's what a lot of you guys think. But, right. And I don't blame you. I do the same thing as a student. You with me? Does that make sense? So just knowing they both gave a C average was not good enough. If I know the spread of grades to expect, I can then make a decision. So very often, if I just give you two numbers, the center and the spread, I don't even have to know what the numbers are. That gives me a really good idea of the data itself. So I can take 8,000 data points and give you two numbers and summarize the data. That's pretty good, right? So what this is called is standard deviation. Now, somehow, let's see if we can do this. Can you bring the lights back up for me? Yeah, thank you. Come here, chair. Go away. Somehow we're going to do this. All right. So. Let's have, let me make a different list of data, a smaller list of data to make it quicker to work with. All right. So there's some data there. Is that really, really spread out? Not really. So whatever number we come up with, whatever formula we come up with, the number should be relatively small. If you had to take a guess, how far away... So here's the thing. I haven't said this phrase yet. I want this number to be the average distance the data gets away from the middle. Let me say it again. The average distance the data points get away from the center. Doesn't that sound like a really good definition of spread? Yes or no? Do you guys agree? In the interest of time, I'm just going to cut to what it is instead of trying to get you guys to get there yourself. Just accept that's what it is. What's the average of this? What's the average of these numbers? 5. Yeah, it's symmetric around 5, so the average is going to be 5. Is that cool? I like it. Or you can add them all up or whatever. So I know that the average, and let me say this. Let's say this is a very small population. This is going to change a little bit if it's a sample. So that means that, what is 5? What's the symbol I use for 5? Careful, it's a population. Mu. A little Greek dude for population. All right, now, let's go back to what we accept, since Jeff basically just told us, but now it makes sense, right? The average distance the data points get from the center. How am I going to calculate that? How do I calculate the average anything? I first have, like, how would I get the average age? I'd first have to get everybody's age. So if I want to get the average distance from the middle to every data point, I first have to get how far away every data point is from the middle. So I'd have to do, put in symbols what I got to do. My data point minus the mean. Is that cool? That's how I figure out what's distance in math. Subtract. To be honest, it's absolute value, but we're going to have to throw absolute value out, and I'll tell you why maybe in a minute. So what do I put here then? Yeah, 3 minus 5? Negative 2. Negative 1. 0. 2. Now what are these? Now if I average these, the same thing will happen every time. What do I get when I add these up?
0.
There'll always be equal negatives and positives. So this is like shit. This is bullshit. Thanks, Jeff. Way to take us down this freaking path. Now, does everybody see this? They're going to have equal amounts negative as positive because the mean is the middle of the numbers, right? Not the middle number, but the middle of the values. So you're going to have equal negatives and positives. This is always going to add to 0. I could take an absolute value. But again, in the interest of time, what does an absolute value look like? Not this. I mean, if you graph it, anybody remember what it looks like? Absolute value. There it is. Is this a plane you want to be on? We're flying along, everything's fantastic, we're going to, bah! You're dead. You can't handle that graph, right? This is a horrific graph. Math, we don't like this kind of graph because it's just so jarring. The slope here is -1, now it's 1. Holy shit. So we don't like that. So instead of absolute value, why would absolute value be a good idea in the first place? Because there's no negatives. And absolute value, if you remember, is distance. Remember that? Absolute value is the distance from 0. That's why it's always positive. So instead what we do, since that kind of shit would happen to us, what's the other thing that would always come out positive? If I squared it. Good. So that's what we end up doing. Because what's a square look like? Here we go flying along, and we turn. Yay, we're all alive. All right. I mean, that seems like a really silly thing I'm talking about, but it really is a big point that that's such a sharp curve. All right, so here I get x minus the mean. Why did I give myself so little room? Squared. I have a handout on this with a whole worked out example, by the way. This will be nice. Obviously, still copy this down. So what do I get here? I get 4, 1, 0, 1, 4. So now listen. Why did I have to square? To get rid of the negatives. Kind of give it away here. What am I going to have to do at the end then? Square root. If these are dogs owned by people, this is like square dogs. Right? Cubist kind of weird ass. Get that weird. Come here. Ah! What the hell is that? Those cube dogs comes running. So I probably at the end of this problem want to take a square root. Does that make sense? So you can kind of follow the logic. And this is like the first time you guys get exposed to constructing a formula to do something you want. You normally are like, this is the formula, y equals mx plus b, use it. But this is like, we want this. We want a measure of spread. All right, oh shit, we got a square. Okay, shit, we better square root later. You can see the thought that went into this. So now I can do, so what I'm going to do now is going to average the square distances and then square root. Because what's the spread going to be? The average distance from the mean to the data points. Right? So right now, if I add these up, how do I average these? I add them up. What do you get? 10. That's amazing. Now what symbol would I put here? Sigma? Yes, because I added these up. There. Kick ass. And then what am I going to do with that? Divide by? No. I'm taking the average, and how many things do I have? 5. So, the standard, let me see. First off, let's just do this. So if I take the sum of these divided by n, that's something called the variance. And the symbol, you're going to love this shit. Remember, if I square root it, that is called the standard deviation. And what letter does standard deviation start with? S. So we want to use the Greek letter S. We already used the capital letter S. It's right there. So let's use the lower letter S in Greek, which looks like a fat R. Poor little dude. Start at the belly and go out to the head, right? Start at the belly, go out. Start at the belly, go out. Start at the belly, go out. It's not hard to make, but it's new for us. Depending on my mood, I get these skinny R's or I get these fat ass R's, but oh well. You guys all right so far? Why is it a Greek letter?
Population.
Beautiful. So what letter am I going to use if it's a sample? Freaking S. Right? We're going to say it's a freaking S. So this is before I took a square root, right? So it's sigma squared. Okay, I like it. So for us right now, this is just kind of like not done. I take a square root, now I get the standard deviation. So let's do it for this data. So this will be, for the variance, it'll be, what do I put here? Yes, I don't put anything here. I don't put any. This whole thing is 10. That is new to us. We're used to replacing individual letters with stuff in algebra. Well, here I know what the hell this whole thing is. So wherever I see this, I put a 10. And what's n? 5. So the variance is 2. So what's the standard deviation? Put a little tilde for approximately. Standard deviation, you always go out at least 3 decimal places. Let me say that again. In fact, let me just say this right now. If you take everything out to 4 decimal places in this class, you are covered. Probability, we're going to go out to 4 places. Standard deviation has to go out at least 3 places. There's going to be some other stuff. So if you're like, what the shit? Just like everything in 4 places, you'll be fine. You with me? So it's got to be at least 3 places. And does this make sense? Yeah, look. 3 is 2 away from 5. 4 is 1 away from 5. That's like a 1.5 average. But 5 is right on top of itself, so it's a little less than 1.5. Does that make sense? I hope so. Okay. So here, let me give you this handout.
Test is on Monday for all this?
Yeah. Yeah. It's kind of insane. We're gonna make a formula sheet.
We are? Or?
Yeah, we are together. We already did basically. There's not too many formulas yet. So just to make sure you understand what's happening with that, on Monday, you can bring with you a formula sheet. It does not have to be on a 8x5 index card or something. You don't have to write it on a grain of rice. I always love that. You can bring as many sheets as you want to that have formulas on them, but they can only have formulas. I'm going to tell you exactly what you're allowed to have on them. Okay? So on one side of this sheet is a worked out example. On the back is a problem I want you to do right now. While you guys start on that, I'm going to give you guys the answer key to the practice test. Huh? This is going to be on the test. Yeah. Session. Oh.